Hi students, problem number 2. Consider a mixture of 2 moles of helium and 4 moles of oxygen. Compute the speed of sound in the gas mixture at a temperature 300 Kelvin. So the problem is looking as very small, but the solution to this problem needs some challenge. So this is a problem for challenging students. Now what are the given quantities I have summarized here. The number of moles of helium is 2. So I take the symbol small n1 is equal to 2. The number of moles of oxygen, so that is 4 moles. So n2 is equal to 4 moles. Then helium is monoatomic gas, is it not? Monoatomic gas. So 4 gram is equal to the molar mass of helium. So I have written molar mass of helium is 4 gram per mole. Similarly, the molar mass of oxygen is diatomic, is it not? So 16 into 2 is 32. So the molar mass of oxygen is 32 gram per mole. Once again I have taken the symbol capital M1 and M2 for the molar mass and expressed in a SI unit, kilogram per mole. So the molar mass of helium is M1, that is 4 gram is converted into 10 power minus 3 kilogram per mole. Similarly, for oxygen, M2 is equal to 32 gram per mole becomes 32 into 10 power minus 3 kilogram per mole. So now we have to find the net mass of the mixture. Okay. So the mass of the mixture directly we cannot add. Okay. How many number of moles are there? No. So the mass of the mixture. M mixture we have to find out. So this is N1 mole into mass of the helium plus N2 moles into mass of oxygen whole divided by N1 plus N2. So this is now equal to N1 is 2. So 2 mole into mass of helium is 4 into 10 power minus 3. So this is 4 into 10 power minus 3 in bracket plus number of moles N2 is equal to 4. So for oxygen 4 into mass is what? 32. So this is 32 into 10 to the power of minus 3 whole divided by N1 plus N2 is 2 plus 4. So this is now equal to 4 into 2 is 8 plus 4 into 32 is 128. So this is 128. Common factor is what? 10 power minus 3. So this is 10 power minus 3 and divided by 4 plus 2 is 6. So that this is equal to 128 plus 8 is 136. So 136 divided by 6 into 10 power minus 3. Therefore, mass of the mixture is equal to, once again, this can be divided by 2. So 136 by 2 is 68. So this is 68 divided by 3 2s are 6 into 10 to the power of minus 3 and kilogram per mole. Okay, this is a kilogram per mole. So mass of the mixture we have to find out first. Secondly, we have to find out the value of Cp and Cv. Then we have to take the ratio of Cp by Cv is equal to gamma for the mixture we have to find out. So I will take first for helium. Okay. So for helium, the Cv is taken as suffix 1. So what is the helium is monoatomic, is it not? Monoatomic means what? This is equal to 3 by 2 R. 3 by 2 into R. And for oxygen, since it is diatomic, the value of Cv is taken as Cv2 and that is equal to 5 by 2 R. These two informations we have to remember. We have studied in the previous chapter itself, thermodynamics and kinetic theory also. We have studied specific heat capacities, isn't it? Molar specific heat capacity of helium is 3 by 2 into R for monatomic gas, and for oxygen it is 5 by 2 into R because it is a diatomic gas. Now we have to once again find what is the common value. Okay, so therefore the CV for the mixture of the two gases we have to find out. That is denoted as CV for the mixture. So this is once again N1 into CV1 plus N2 into CV2 whole divided by N1 plus N2. These formulas you have to write and practice. Okay. So now children, this is equal to N1 is what? 2 into CV1 is what? 3R by 2. So this is 3R by 2 plus 4 moles. N2 is equal to 4 moles into 5R by 2. So this is 5R by 2 whole divided by 2 plus 4. So this is now equal to what? After cancelling this 3R. So this must be equal to, first we have to write 3R plus here after cancelling these two, 5 into 2 is 10R. Okay. So divided by 2 plus 4 is 6. So this is equal to 13 by 6 into R. So this is a CV for the mixture. So from Mayer's relation, therefore I can find CP for the mixture. CP for the mixture is equal to what? CV mixture plus R. So this is equal to, so here I will write this is equal to 13 by 6 into R plus R. So that this is equal to, taking LCM, 13 plus 6. So this is 19 by 6 into R. Okay, 19 by 6 into R. So this is the CP value for the mixture. Therefore, the value of gamma for the mixture is equal to CP by CV for the mixture. So that this is equal to CP is what? 19R by 6. The reciprocal I will multiply 6 by 13. Okay, 6 by 13. R and R get cancelled. So that this is 6 and 6 also get cancelled. So this is equal to what? 19 by 13. So up to this first initial calculation we have to do. Okay, my dear students, first we have to find the common mass of the mixture. Second, the common value of the CV for the mixture. From that we have to get the value, common value for CP for the mixture, and then take the ratio of CP by CV for the mixture. You will get gamma value for the mixture. Now what is given here, temperature is 300 K and the gas constant R is 8.31. We must know that is a constant. So I will write here gas constant R is equal to 8.31 joule per mole per Kelvin, and T is equal to what? 300 Kelvin. Therefore the velocity of sound through the mixture of gases is equal to, this is gamma of the mixture times R into T divided by the mixture mass, the mass of the mixture. So this is now equal to square root. Gamma for the mixture is how much? 19 by 13. So I will write here 19 by 13 into 8.31 is the gas constant, 8.31 into T is how much? 300 K. So this is 300 whole divided by, what is the mass of the mixture? Mass of the mixture is how much? 68 by 3 into 10 power minus 3, or 68 by 3000, is it not? So here this is 68 divided by 3. So that 3 is going up into 10 power minus 3 is here, is it not? Here this is a 10 power minus 3, that is going up as 10 power 3. So how I have substituted this value 68 by 3, this 3 is in the denominator, so here we have to write it in the numerator. Then 68 into 10 power minus 3 should be written, that 10 power minus 3 is going up. Okay, so 68, that 10 power minus 3 goes up as what? 10 power plus 3. Now this is equal to square root of 19 into 8.31. Now this this one can be written as 83.1. I am going to shift this 83.1. So this is 83.1 means I have multiplied by 10. So this power I can reduce as 10 power 2, is it not? So 83.1 I have written into here 300. So this is 300 into 3000 is there. 110 I have multiplied here. So this will be what? 300 whole divided by 13 into 68. Okay, so this 3 into 10 power 3 is 3000. 110 I have multiplied here. 8.31 has become 83.1. So 300 into 300 is inside the square root, means one of these can be taken out. So this is now equal to 300 into square root of. Now I am going to use the calculator. So 19 into 83.1. 19 into 83.1. So this is equal to 1578. So this is 1578.9 divided by 13 into 68. 13 into 68. So this is 884. So this is 884. So this is equal to 300 into square root of. We have to find the ratio, is it not? 1578. So 1578.9 divided by 884. So this is coming as 1.786. 1.786. So now we have to find the square root of 1.786. So square root of 1.786. So this is now equal to 300 multiplied by the square root value is 1.336. 1.336. So if you multiply 300 into 1.336. 1.336. So this is coming as 400.8. So V is equal to, therefore V is nearly equal to 400 meter per second. So this is the nearest answer. Okay, my dear students, first what I told, you note down the number of moles as N1 and N2. Then what is the molar mass? Molar mass for helium and oxygen you find out. Then multiply by them into number of moles and get the mass of the mixture of gases. So first step is to find the mass of the mixture of gases. The next step is what? To find the molar specific heat capacity CV for the mixture, and then from Mayer's relation Cp for the mixture we found, and after that take the adiabatic constant or adiabatic exponent gamma equal to Cp by Cv for the mixture. Then we have to substitute in the general formula. Understand that? So the velocity of the sound in gas is given by square root of gamma into RT by M. So gamma for the mixture and the mass of the mixture if you substitute means we can get the answer V equal to 400 meter per second. I hope you must have understood well. Fine.